Determining an appropriate demand factor for fitness equipment necessitates considering several things. Firstly, the type of equipment is a major factor, as different types of equipment have varying power consumption levels and duty cycles. Secondly, usage patterns must be taken into account, as the frequency and duration of equipment use can vary depending on the time of day, the day of the week, and the season. Equipment specifications also matter, with nameplate ratings typically indicating the maximum power consumption of the equipment. The consideration of an 80% demand factor versus a 100% demand factor is also important. The 80% demand factor is commonly used in fitness centers to account for the fact that not all equipment will be operating at full capacity simultaneously. This factor assumes that 80% of the connected load will be operating at any given time. A 100% demand factor, on the other hand, assumes that all equipment will be operating at full capacity simultaneously, a conservative approach that may lead to oversizing the electrical system. In general, the 80% demand factor is considered reasonable for fitness centers based on industry experience. Studies have shown that the actual demand for gym equipment typically ranges from 50% to 75% of the connected load. In addition to the demand factor, consider other factors when calculating loads for fitness centers. The type of electrical distribution system, such as panel boards or feeders, should be designed to handle the expected load. Circuit breakers should be sized appropriately based on the demand factor and connected load. Also, the electrical system should be designed to accommodate potential future expansion of the fitness center. Therefore, based on industry experience and the factors mentioned, the 80% demand factor for fitness equipment appears to be a reasonable value. However, consult with local authorities and experienced electrical engineers to ensure compliance with applicable codes and safety standards. Let's delve deeper into each of these considerations. Examining the types of equipment found in a fitness center, there's a wide range, each with unique power requirements. Treadmills, elliptical trainers, and stationary bikes often have varying levels of resistance and speed, impacting their energy draw. Weight machines, while not always directly electrically powered, may still contribute to the overall load through control systems or displays. Tanning booths are high-demand appliances requiring substantial power for their ultraviolet lamps. Even seemingly minor equipment like televisions, sound systems, and ventilation fans add to the cumulative load. Each piece of equipment should be individually assessed for its maximum power consumption typically found on the nameplate, but also its typical operational power draw. Understanding how the equipment is used is crucial. A gym that's packed during peak hours will have a higher demand than one that's mostly empty during off-peak times. Consider the demographic using the fitness center. Are they primarily focused on cardio, weightlifting, or a mix of both? Are there specific classes offered at certain times that heavily utilize specific equipment? Collect data, if possible, on equipment usage patterns to refine the demand factor calculation. This can be done through observation, member surveys, or even monitoring the power consumption of individual circuits over time. The nameplate rating provides the maximum power a device can consume under ideal conditions. However, this is rarely the sustained power draw during normal operation. A treadmill, for instance, might have a 2-horsepower motor, which translates to roughly 1500 watts, but it only draws that much power when running at maximum speed with a heavy load. Similarly, tanning booths may have cycles where the lamps are at full intensity, but also periods where they're dimmed or off completely. Use the nameplate rating as the upper limit, but factor in realistic usage scenarios to determine the actual power consumption. When it comes to demand factors, there isn't a one-size-fits-all solution. The 80% demand factor is a common starting point, but it's not a guaranteed safe value for every situation. It's crucial to understand the assumptions behind that number. It assumes that, on average, 20% of the equipment will be idle at any given time. Consider whether this assumption is valid for the specific fitness center being designed for. If the gym is known for being exceptionally busy, or if it has a unique layout that encourages simultaneous use of equipment, then a higher demand factor might be warranted. Conversely, if the gym has a large selection of equipment with low utilization rates, a low demand factor could be considered. The 100% demand factor represents the worst-case scenario where every piece of equipment is running at its maximum power draw simultaneously. While this is highly unlikely, it provides the most conservative estimate for the electrical load. Using a 100% demand factor will result in a larger electrical service, larger panels, and larger conductors, which translates to higher upfront costs. However, it also provides the greatest margin of safety and ensures that the electrical system can handle any potential load without risk of overloading. It's important to weigh the costs and benefits of each approach. Industry experience can provide valuable insights into the typical demand factors observed in similar fitness centers. Consult with experienced electrical engineers, contractors, and facility managers who have worked on similar projects. They can share their experiences and provide data on actual power consumption patterns. Look for published studies or reports on energy usage in fitness centers. These resources can provide benchmarks and guidelines for determining appropriate demand factors. Local authorities may also have specific requirements or recommendations for demand factors in fitness centers. Be sure to check with the building department or electrical inspector to ensure compliance with local codes and regulations. The electrical distribution system must be designed to handle the calculated load, including the demand factor. The main service entrance, panel boards, feeders, and branch circuits must be sized appropriately to carry the anticipated current. Consider the voltage drop in the system. Excessive voltage drop can lead to equipment malfunction and reduced performance. Size conductors appropriately to minimize voltage drop and ensure that equipment receives the proper voltage. Ensure that the electrical distribution system is properly grounded to protect against electrical shock and equipment damage. The grounding system should comply with all applicable codes and standards. Circuit breakers are essential for protecting electrical circuits from overloads and short circuits. Circuit breakers must be sized appropriately based on the demand factor and connected load. Select circuit breakers with the correct interrupting rating to handle potential fault current. Coordinate circuit breakers to ensure that only the affected circuit trips in the event of a fault. This minimizes disruption to other parts of the electrical system. Consider the potential for future expansion when designing the electrical system. It's often more cost-effective to install a slightly larger service and panel boards initially than to upgrade the system later when the fitness center expands. Provide spare capacity in panel boards and raceways to accommodate future circuits. Consider the potential for adding new equipment, such as additional treadmills, weight machines, or tanning booths. Design the electrical system to handle the increased load without requiring major modifications. The National Electrical Code, or NEC, provides guidelines for calculating electrical loads and selecting appropriate demand factors. Refer to the relevant sections of the NEC for specific requirements and recommendations. NEC Table 220.42 provides demand factors for non-dwelling receptacle loads. Consult with a qualified electrical engineer to ensure compliance with the NEC and other applicable codes and standards. Understanding the different types of fitness equipment is vital for accurate load calculations. Treadmills often have a horsepower rating indicating their motor's power. Convert horsepower to watts, remembering that 1 horsepower is approximately 746 watts. Elliptical trainers typically have a lower power consumption than treadmills, but still require consideration. Stationary bikes may have a generator that produces electricity, but this is usually not factored into the overall load calculation. Weight machines, even those without electric motors, may have electronic displays or control systems that require power. Tanning booths are significant power consumers due to the ultraviolet lamps. Determine the wattage of each lamp and the total number of lamps in the booth to calculate the total power consumption. Don't forget to include the power consumption of auxiliary equipment such as ventilation fans and control systems. TV and sound systems, while relatively low in power consumption, still contribute to the overall load and should be included in the calculations. Consider the lighting load in the fitness center. Fluorescent and LED lighting are more energy efficient than incandescent lighting, but still require power. Calculate the total wattage of all lighting fixtures and include it in the overall load calculation. Emergency lighting systems must be included in the load calculation. Emergency lighting is typically powered by a backup generator or battery system and must be able to operate for a specified period of time in the event of a power outage. Consider the HVAC system load. Heating, ventilation, and air conditioning systems can be significant power consumers, especially in large fitness centers. Calculate the cooling and heating loads based on the size of the space, the number of occupants, and the climate. Consider the hot water system load. Fitness centers often have showers and locker rooms that require hot water. Calculate the hot water demand based on the number of showers, the frequency of use, and the temperature of the water. Review the equipment layout and consider how it might affect equipment usage. If equipment is tightly packed together, it's more likely that multiple machines will be used simultaneously. If equipment is spread out, there may be more downtime between uses. Observe how members use the equipment during peak and off-peak hours. This can provide valuable insights into actual demand patterns. Talk to fitness center staff and managers to gather information on equipment usage patterns. They may be able to provide information on which machines are most popular and when they are most frequently used. Install power monitoring equipment on individual circuits or panels to track actual power consumption over time. This data can be used to refine the demand factor calculation and optimize the electrical system. Consider the impact of energy-efficient equipment. Replacing older, less efficient equipment with newer, energy-efficient models can reduce the overall load on the electrical system. Incentivize members to conserve energy by offering rewards for using equipment during off-peak hours or participating in energy-saving programs. Educate members about the importance of energy conservation and how they can help reduce the fitness center's environmental impact. Consider the use of renewable energy sources such as solar panels or wind turbines to offset the fitness center's energy consumption. This can reduce the reliance on the grid and lower energy costs. Implement a power management system to automatically control lighting, HVAC, and other equipment based on occupancy and time of day. This can help reduce energy consumption and lower operating costs. Perform regular maintenance on electrical equipment to ensure that it is operating efficiently. Faulty or malfunctioning equipment can consume more power than necessary. Consider the use of a demand response program. These programs allow the utility company to temporarily reduce the fitness center's power consumption during peak demand periods in exchange for a financial incentive. Investigate the availability of rebates and incentives for energy-efficient equipment and practices. Many utility companies and government agencies offer programs to encourage energy conservation. Consider the location of the fitness center. Fitness centers located in warmer climates will typically have higher cooling loads than those located in colder climates. Fitness centers located in areas with high electricity rates will have a greater incentive to conserve energy. Consider the demographics of the fitness center's members. Fitness centers that cater to athletes or bodybuilders may have higher equipment usage rates than those that cater to casual exercisers. Document all assumptions and calculations used to determine the demand factor. This will help justify the design to the owner, the electrical inspector, and other stakeholders. Regularly review and update the demand factor calculation as equipment is added, removed, or replaced. This will ensure that the electrical system remains appropriately sized for the fitness center's needs. Communicate the demand factor calculation and its implications to the owner and other stakeholders. This will help them understand the importance of energy conservation and the impact of equipment usage on the electrical system. Provide training to fitness center staff on how to operate equipment efficiently and conserve energy. This can help reduce energy consumption and lower operating costs. In conclusion, accurately determining the demand factor for a fitness center's electrical system is a multifaceted process that demands careful consideration of various factors. By thoroughly analyzing equipment types, usage patterns, and industry best practices, and by engaging with experienced professionals and local authorities, you can develop an electrical system that is both safe and efficient, meeting the current needs of the fitness center while also providing for future growth and expansion. Remember that the 80% demand factor is a common starting point, but it should be carefully evaluated and adjusted based on the specific characteristics of the facility. A conservative approach, while potentially increasing initial costs, can provide peace of mind and ensure reliable operation in the long run.